In the previous video, I have calculated charges on various surfaces of a parallel plate conductor. In this video, uh, we have to calculate potential difference between two plates. Particularly in this question, a charge of 1 microcoulomb is placed on the upper plate, placed over here, and we have to calculate the potential difference between upper and middle plate, that is these two, and middle and lower plate, that is this. And the charge of 1 microcoulomb, this 1 microcoulomb is given on the top plate, this one. So in my previous videos, the links are given in the description below. I have mentioned, or I have discussed the theories related to these types of problems. So if you are interested, you can see. So let us solve this problem. Now we have three parallel plate capacitor or parallel plate conductor. The notations, this again I have discussed it earlier also. So these are the notations for the phases. F1L represent the phase on first conductor on the left side. F2L represent, this is our first plate. F1R represent the phase on the first conductor on its right side. Similarly for second, it is F2L for the left plate and F2R for right plate. Likewise for this third plate, it is F3L and F3R. Now in our question, it is given that Q1, that is on the first plate, the charge is 1 microcoulomb. It is initially given to this plate. Q2 and Q3 are given as 0. Now in our previous video, we have discussed and we have derived this value, that Qt, that is the charge appearing on this extreme left face, that is on F1L, and on extreme right face, that is on F3R, is sum of all the charges divided by 2, and both means on this F1L as well as on F3R, both the values are same. So Qt is Q1 plus Q2 plus Q3 plus Q1 plus Q2 plus Q3 divided by 2, and this will be same on F1L as well as F3R. So if we substitute these values, we get Qt equals to 0 plus Q plus 0 divided by 2, that is Q by 2. Now this we have calculated. So Qt is Q by 2 and Q by 2. This will be same on both the plate. For detail, you can, I am again repeating, you can see my previous videos. The links are given below. Now the theory which we have discussed earlier also, that this first plate, which is an isolated plate, so total charge remains constant. So charge on F1R will be this capital Q minus Q by 2, that is Q by 2. Now from Gauss law, we can say that charge on F2L, that is on this face, F2L will be minus Q by 2. Again, this plate was an isolated, it was given a charge. Initially there was no charge given to this plate, it was neutral. So net charge on this should be 0. So on F2R, the charge should be Q by 2. Similarly, from Gauss law, we can say that if Q by 2 is appearing on this F2R, then from Gauss law, minus Q by 2 will appear on F3L. And since this plate is neutral, you can verify, because we have earlier calculated that this value has to be Q by 2, and this value we have calculated starting from our left face, and this value is coming out to be minus Q by 2. So you can verify your answer, that minus Q by 2 plus Q by 2 equals to 0, which was the initial charge that was given to this third plate. So we can verify the charge distribution also. Now we have to calculate the potential difference between first and second plate as well as second and third plate. This is our first plate, and the capacitance of this plate is given as 50 nanofarad. This is our first plate, this is our second plate, and this is our third plate. So capacitance is a pure geometric consideration, and this is epsilon naught A by D, where D is the separation between these two plates, which is same for both the plates. So here this D is epsilon naught A into D is given as 50 nanofarad. We will use this expression to calculate the potential difference. Now the charges on each plate we have just now calculated, and we have derived in our previous video that the potential difference between plate 1 and 2 is proportional to this charge Q by 2, and that equals to, that is V12, we can write it as charge on this plate, that is Q by 2 into epsilon naught into A, this whole multiplied by D. So V1 minus V2 is Q by 2 epsilon naught A. I have put this value D below here. So it is Q by 2 epsilon naught A into D. Now substituting the value of epsilon naught A by D as 50 nanofarad, we obtain the expression like this one, and when we calculate this value we get this potential difference as 10 volt. In the same manner, when we calculate potential difference between 2 and 3, again we have derived that the potential difference between the two plates is proportional to the charge which is appearing on the face of the plate between 2 and 3. In this case it is Q by 2. So V3 minus V4 is Q by 2 epsilon naught into A, this whole multiplied by D, that is Q by 2 epsilon naught A, and I have substituted this D from numerator to this denominator of this. When we substitute the values of Q as well as epsilon naught A by D, which is given as capacitance here, that is 50 nanofarad, we obtain the same result, 10 volt. So finally we are able to calculate this potential difference between these two plates 1, 2 as well as 3, 4, and this is what was required in the question. Thank you.